Okay, so on the notes today, we're going to be looking at radicals. So at this top part where it says factor, I'm just going to skip over that because that's just a review. You can look back at your factoring notes for those. So we're going to start with number 5 on the notes. So we are simplifying the radicals. When you're simplifying a radical, you're first checking to see if it's a perfect square. If it's not a perfect square, then you're going to use the factor tree. So on number 5, 56, if you take the square root of 56, you're not going to get a whole number, so we're going to use the factor tree. So on the factor tree, you're going to first start out with I like to start out with the smallest number that will go into that, which would be 2, besides a 1. So 2 times 28, and then we're going to continue on. So once you've reached a prime number, you're going to stop. A prime number is a number that can only be divided by itself and 1. So 2 is prime, but 28 is not. So we're going to draw a factor tree off of that. I'm going to start with 2 times 14, and then 2 times 7. After I draw a tree off of it, I like to mark out the numbers that I drew trees off of, so that way I'm only looking at the prime numbers. Okay, from here, we're taking the square root of 56, so you're looking for pairs. So I have a pair of 2's because 2 times 2 would give you 4. The square root of 4 is 2. So those pairs we'll be bringing on the outside of your radical, and then whatever is left that doesn't have a pair, I want you to box in, and that's going to stay under your radical. So I'm bringing out a 2 because I had a pair of 2's, and then under the radical would be 14. So if you have more than one left over, you would multiply them to get an answer. Okay, so these should be equal. So if you typed in square root of 56 on the calculator and got a decimal, 2 square root of 14 should be the same decimal. So those should be equal. Okay, so looking at number 6, square root of 324. First check to see if it's perfect. 324 is a perfect square. So the square root of 324 would give you 18. If you did not check that at the beginning, then when you use the factor tree, you should have ended up with all pairs and nothing that didn't have a pair. So that's why it would be perfect there. Okay, so let's look at 7, square root of 98. So that's not perfect, so we'll start with 2. 2 times 49. 2 will not go into 49. 7 will, so 7 times 7. We're looking for our pairs, so circle your 7's. We're going to bring that on the outside, and then we have left a 2. So 7 square root of 2 should be the same decimal as the square root of 98. So we're just bringing all of our perfect squares out of our radical. Okay, so number 8, we have 5 square root of 300. So for now, we're just going to ignore the 5 and just look at the 300. So if you looked at the square root of 300, that's not a perfect square. So we're going to use the factor tree to simplify it. So I'll start with 2 times 150, and then 2 times 75. 2 will not go into 75, but 3 will. 3 times 25, and 5 times 5. Now notice that we already had a 5 on the outside. Bring that over whenever you're writing your answer here. And then if you're bringing numbers out, you'll be multiplying it by that 5. So notice I have a pair of 2's, so I'll bring a 2 out. And then notice I have another pair, and I have a pair of 5. So I'm going to multiply all of those together, whatever I'm bringing out. And then the 3 is what's boxed in, so that stays under the radical. So square root of 3. Now go ahead and multiply those numbers on the outside together. So that would be 5 times 2, which is 10. Times 5, you get 50 square root of 3. And again, 5 square root of 300 should equal 50 square root of 3 when you type that into the calculator. It should be the same decimal. Okay, so let's look at number 9. Notice here that we have a radical in the denominator. You should have learned in geometry or before that that you cannot divide by a radical. So you are going to rationalize this fraction, which means you're going to get rid of the radical. Anytime you're wanting to get rid of a radical, you multiply it by itself and it gets rid of that radical for you. Okay, so if I wanted to multiply this fraction by the square root of 3, because that's what that number is on the bottom, I would have to do the same exact thing to the top here, because the square root of 3 divided by the square root of 3 is 1. So when I times something by 1, I'm not changing the value of it, okay? All I'm doing is I'm just trying to write it a different way. So on the top here, when you're multiplying radicals, you can only multiply outside terms and inside terms. So notice this 4 is on the outside, so I would have 4 and then square root of 3. So I could not multiply 4 times 3 there. The denominator, square root of 3 times the square root of 3 is the square root of 9, which equals 3. So anytime you're multiplying a radical by itself, it gets rid of the radical, and you're just left with a radicand, which is the term under it. At this point, once you get this answer, you need to check and see if you can reduce 4 divided by 3, those outside numbers. We can't reduce it, so that would be our answer. But always check to see if you can reduce. Okay, so 10. Notice this one's different than 9. Notice that we have a radical and we have a constant with that radical in the denominator. So if we were to multiply it by square root of 5, we would not end up getting rid of the radical, because you would have to do 2 times the square root of 5, which would give you 2 square root of 5. So you would have another radical in the denominator. So what you have to multiply by is the conjugate. So it's square root of 5 minus 2. So it's the opposite sign there in between your two terms. So square root of 5 minus 2. If I did that to the denominator, I have to do the same exact thing to the numerator. Okay, so on top here, when I multiply, I'm multiplying 5 times square root of 5, which is 5 square root of 5. And then I also have to multiply 5 times a negative 2, which is a negative 10. Notice the denominators here. I'm multiplying a binomial times a binomial, because I have 2 terms and then another 2 terms. So I have to use FOIL. So square root of 5 times square root of 5 is just 5. Square root of 5 times negative 2 is a negative 2 square root of 5. 2 times square root of 5 is positive 2 square root of 5. And then 2 times a negative 2 is a negative 4. Excuse me. Okay, so notice the top here. Radicals are the same thing as variables. Okay, so very similar when you're adding and subtracting. Okay, so when you're adding and subtracting, you can only add or subtract the things that look the same. So if I have a square root of 5, I can only combine it with another square root of 5. But notice I don't have that. So I'm just going to leave it. You can write it as 5 square root of 5 minus 10, or negative 10 plus 5 square root of 5. Denominator, notice that these middle terms cancel. That's why you're multiplying it by the conjugate. And then you just have 5 minus 4, which is 1. So I don't have to put over 1 here, so that would be my answer. Okay, let's look at the next page. Now we're going to get into actually solving. So we're solving here using the square root method. Square root method can only be used whenever you are missing your middle term, which is your x term. So only used when missing x. Okay, so notice on 11 we're missing the x term. What you will do when you're using the square root method is get the term or terms that's squared by itself. Okay, so I need to get x squared by itself. So I would add 49 to both sides. And then you should have learned in geometry, especially when you were using the Pythagorean theorem, a squared plus b squared equals c squared. To get rid of that squared, you're going to do the opposite of it, which is take the square root. So I'm going to take the square root of both sides. Square root of x squared is x. And then the square root of 49 is 7. Now, yesterday when we were solving quadratic equations by factoring, most of the time you're going to get 2 answers, 2 solutions. Okay, so on these you will also get 2 solutions, because if you were to plug this back in here, 7 squared will give you 49, but also a negative 7 squared would give you 49. So make sure you put positive and negative 7 for your solution, because you're trying to find all the possible solutions. Okay, so let's look at 12. we're going to get x squared by itself. So first step would be to add 27. And then divide by 3. So x squared would equal 9. And then we take the square root of both sides. So x would equal square root of 9 is 3. But remember, a positive and a negative 3 squared would give us 9. Okay, so 13. First step would be to add 48 to get x squared by itself. Once you have x squared by itself, then you can take the square root of both sides. So on the other examples, we had perfect squares. 48 is not a perfect square, so you need to use the factor tree to simplify the radical. So 2 times 24, 2 times 12, 2 times 6, and 2 times 3. So I have a pair of 2's and another pair of 2's, and then I have left a 3. So we're bringing 2 2's out, which would be 4, and then square root of 3. Positive and negative 4 square root of 3. You could plug in, if you wanted to check any of these, you could plug them back in. For x, it should be true on your original equation. Okay, so 14. First step would be to add 60. So we have 10x squared equals 80. And then we would have to divide by 10. So x squared would equal 8. And then we'll take the square root. Square root of 8 is not a perfect square, so use factor tree to simplify it. We have a pair of 2's, and then I have left a 2. So positive 2 square root of 2 and negative 2 square root of 2 would be your solution. Okay, 15 is a little different because we have an x squared and it's inside parentheses here. So first I want you to circle your term that's squared, so it's x squared. You could first distribute the 2 inside, and then you could solve for x squared. But I'm going to get rid of the 2 first. So I'm going to divide both sides by 2. And so I'm left with x squared minus 3 equals 5. And then I'll add 3. So x squared equals 8. And then notice that's similar to what we just had, or it is the same thing that we just had on 15. We take the square root of 8. We get a positive and a negative 2 square root of 2. Okay, so last one. Notice that this time x is not the only thing that is squared. So circle what's squared. X plus 3 is squared. I need to get whatever is squared by itself. So I'm going to divide by 2. So x plus 3 squared equals 8. Now I can take the square root because I have my terms that are squared. So when you're taking the square root of a squared term, they just cancel each other out. So you're just left with whatever term is under the radical, which is x plus 3 on this example. Make sure when you take the square root of both sides, you get a positive and a negative square root of 8, which is 2 square root of 2. Now I need to get x by itself, so subtract 3. So x would equal, now we talked about this earlier, when you're adding and subtracting, radicals are just like variables. You can only add and subtract the ones that are the same. This has a square root of 2, the other one does not, so I cannot add or subtract them. So I'm going to put the constant first, negative 3, and then plus and minus 2 square root of 2. So I'm going to leave it in that form because I'm not able to add or subtract those together. So that's solving quadratics using the square root method. That's if you're missing your x term, your middle term on the inside.